Consider the three following questions. What degree of a polynomial, how is it related to the number of solutions? Derivative of a function, what do you know about it? And relationship between points on a star. Let's look at these. You know a degree of a polynomial, the exponent matches the number of solutions. If the exponent is 2, there's 2 solutions. If it's 3, there's 3 solutions, and so on. What happens if you turn that exponent into a fraction? How many solutions do you expect? What happens if you turn it into an irrational number? Let's look at the next question. You know the first derivative, second derivative, third derivative, fourth derivative, and so on. Those are easy to calculate. But can you have a fractional derivative? Can you have an irrational derivative? Now, the idea of points on a star is pretty straightforward. You can have 4 points make a cross, 5 points make the common star, 6 points make the hexagram, and so on. But what would it mean to have a fractional number of points on a star? And what would it mean to move between these things? What would it look like if I gradually moved from a, say, 4th degree polynomial to a 5th? What would it look like? How would my solutions change if I tried to gradually move from the 4th derivative to the 5th derivative? Can I convert a 4-point star, that is to say a cross, into a 5-point star? Is that possible? What would it look like? Although these questions might look like totally different questions, perhaps they're all related. Let's look at the picture. Here we have a 4-point star, and with a little bit of effort, we can convert that to a 5-point star. But what if we went between them? What would it be like to be between 4 and 5? Well, let's work our way back from 5 down to 4 and watch what happens. Here's a smooth, unbiased transition from 5 points to 4 points. You'll notice this does not show all the points. This shows an idea of what's going to happen, but you'll notice we go from 5 to an infinite number of points. But as we make our transition, notice how these groups form like right there. A distinct number of points, and it's going to happen again right about there, a distinct number of points. So we keep moving between an infinite number of points and a distinct number of points. What that represents is moving from a irrational number to a rational number, and finally we get to the 4-point star. Let's move back to the 5-point star and notice again, although we see a finite number of points, that's just the technology, not the reality. And as we pass through rational numbers, we see finite number of points as the infinite numbers group up, but as we go through the irrational numbers, we see infinite numbers of points. So between 4 and 5, we see 9 and 7, 11, and a whole bunch of other possibilities. It seems like in the transition from 4 to 5, almost every other integer is actually going to exist. And there we are at 5. So, looking at our original question, we've answered the third one clearly. Points on a star, can we make a transition between 4 and 5 points on a star? Yes, we can do that. Derivatives of a function, can we have a derivative which is not a integer? Perhaps we can, and it might be related to that star we just saw. How many solutions are there if your degree of a polynomial is not an integer? It looks like you get into this weird scenario where the number of solutions you expect might be infinite, or it might be an unusual number which seems to have no reason for being between the two numbers you just saw. For example, 11 and 9 and 7 have appeared between 4 and 5. So these questions appear to have an answer, and they appear to have an answer in that star that we just saw.